All right, when we balance chemical reactions, we know we have to balance the number of atoms on both sides of the reactions. Right, if we got 3 sodiums on one side, we know we have to have 3 sodiums on the other side. With redox reactions, it's the same thing, but we also have to balance the electrons. So it's a little more complicated. And there's different ways to do this, but this is called the half reaction method. This is the one I use. So you're going to learn my method. And it is 6 easy steps, right? These are the steps. You have to learn them. So to begin with, you look at the 2 reactions and you decide who's going to be oxidized and who's reduced, like we've been doing. You really don't need to do this step to do the balancing, but it's something we already know. So really, it comes down to 5 easy steps. First step is to split into the half reactions. So here we're going to practice. Let me read through them. Split into half reactions, and then for each half reaction, you balance all the atoms except O and H by changing their coefficients. You balance the O's by adding waters. You balance the H's by adding H pluses. Then you balance the charge by adding electrons. Then you combine them, you cancel stuff out, and you're done. And there's one other step if you're doing this in basic solution. But let's follow this along. So here's a reaction we're going to balance. We have iron 2 going to iron 3. That's oxidation. We have the dichromate ion going to chromium plus 3. That's reduction. So we split them up into half reactions. So first I'm going to look at the dichromate going to chromium. We said that's reduction. Okay, let's follow the steps. So first we split it into the half reaction. Next we balance everything except O's and H's. And so we have 2 chromiums on this side. So I have to put a 2 here to balance that. Next step, balance the O's by adding water. On this side, the left side, I have 7 O's, so I have to add 7 waters on the other side. Next step, balance the H's by adding H pluses. I have no H's here. I have 14 H pluses, or H's, so I know I have to add 14 H pluses to the left. And the last step is to balance the charge. So let's just look here. What is the charge on this side, the right side? The chromium is plus 3, but there's 2 of them, and this is important. We have to look at these coefficients. So the charge on this side is plus 6. On the other side, dichromate has a minus 2 charge, 14 pluses with the H pluses, so the net charge is plus 12. The last step is to balance the charge by adding electrons. We're adding minuses, the negative charges. And so plus 12 doesn't equal plus 6. But if I add 6 electrons to the left, now plus 6 equals plus 6. That's balanced. See the next one. Looking at the iron, this is the oxidation half reaction. We balance the irons first. All right, they're balanced. We balance the O's by adding water. Balanced. We balance the H's by adding H pluses. Balanced. Then we balance the charge. It's plus 3 on the right. It's plus 2 on the left. Plus 2 doesn't equal plus 3. I'm going to add 1 electron to the right. Now it balances. All right, so this is the balanced half reaction right here. The next step is to combine the 2 half reactions so the electrons cancel. Okay, remember, how many electrons do we have here? 6 electrons on the left. That means I have to have 6 electrons on the right. This reaction only has 1 electron, so to fix that, we multiply the whole thing by 6. So 6 iron 2s plus, it goes to 6 iron 3s plus 6 electrons. Then we combine them. So I just rewrote the same equation, same reactions, those balanced half reactions. We combine them, so 6 electrons, oops, goes there, right? I just bring everything down on the sides of the arrows. We've done this several times in different situations, and we get this. Now my 6 electrons on the left are going to cancel my 6 on the right. Nothing else cancels. But this then is the balanced redox reaction. And if we look at this, it should be balanced for both atoms and charge. So let's just pick a couple things. 6 irons, 6 irons. 2 chromiums, 2 chromiums. 14 H's, 14 H's. 7 O's, 7 O's. Okay, the atom is balanced. Let's check the charge. The right side, the net charge is 6 times plus 3 plus 2 times plus 3. Right, make sure you look at those coefficients. So that'll be 18 plus 6 is plus 14. Bad work. Plus 24. The other side, I got 14 pluses, and I have another 12 pluses. That's a disaster. Oh, thank heavens, we have a -2. So I add that up, and we get 24, balanced for charge. All right, so these are the steps. You should take a second and try to learn these steps. Go ahead and memorize them. And I'm going to go through an example. I'm going to do the same thing the way I would write it. So the first step is to break it up into the half reactions. Right, balance the irons, check. Balance the O's by adding water, check. Balance the H's by adding H pluses, check. Balance the charge by adding electrons. I got 3 pluses on this side, 2 pluses on the left. I know I have to add 1 electron. That guy's done. Let's do the dichromate. Chromium plus. Balance everything except H's and O's. I got 2 chromiums on the left. Means I have to put a 2 here. I balance O's by adding water. I have 7 O's on the left, so I need to add 7 waters. Now I have 14 H's on the right, so I know I have to add 14 H pluses. And then balance the charge. The net charge on the right is +6. Net charge on the left is +12, so I add 6 electrons here. 6 and 2 minuses is -8. 14 minus 8 is +6. +6 equals +6. Balanced. Next, I combine them so the electrons cancel. 6 electrons on the left, 1 electron on the right. I know I have to multiply by 6. So I'm going to multiply and carry it down. So 6 iron 2s plus 6 electrons plus 14 H pluses plus dichromate ion goes to 6 iron 3s plus 6 electrons plus 2 chromium 3 pluses plus 7 waters. Electrons cancel, and so if I take the time to rewrite it, this should be the balanced chemical reaction. Fe3 pluses plus 2 chromium 3 pluses plus 7 waters. All right, balanced. And I could check it and make sure it's true. You can always see if you're right or not, right? You just count up the atoms, count up the charges, and see if you're right. One thing, see how I did this? I did it all in 3 steps, basically, or 3 or 4 steps. Just going down the page. I think this is the easiest way to do this rather than rewriting it. So in the previous example, I wrote the steps and rewrote everything. That just takes a long time. Just add to the left, add to the right until you're done. And then combine them and simplify. Much easier. All right, let's try again. So you should go ahead and try this by yourself. All right. One thing you might, iron 2 plus permanganate is being oxidized to iron 3 plus Mn2 plus. All right, maybe you needed some help there, but now go ahead and follow the 6 easy steps. All right, you've tried it, right? I'm going to do it now. So iron 2, split it into half reactions. Balance everything except H's and O's, done. Balance the O's by adding waters, done. Balance the H's by adding H pluses, done. Balance the charge by adding an electron, balanced. MnO4 minus goes to Mn2 plus. Balance everything except H's and O's, Mn, 1 Mn on both sides, that's done. Balance the O's by adding water, so I need 4 waters on this side. Balance the H's, I have 8 H's on the right, so now I need 8 H pluses on the left. Balance the charge, net charge on this side is +2. Charge on this side is 8 pluses and a minus, so it's, what have I done? Hold on. Oh no. I've done something bad. Hold on, give me a second. 4 waters, 8 H pluses, 8 H pluses. Oh no, I'm okay. Falling into a trap. Too much muttering, no more muttering. +7 on the left, right? 8 pluses and a minus gives me +7. +7 does not equal +2. I need to add electrons, and I add the minuses to the more positive side. So to get to +2, I need to add 5 electrons. So these are the balanced half reactions. Now I combine them so electrons cancel. 1 electron and 5 electrons are not the same, so I need to multiply by 5. Right, I'm going to multiply this whole thing by 5 and carry it down. So 5 Fe, 2 pluses plus 5 electrons plus 8 H pluses plus MnO4 minus goes to 5 Fe, 3 pluses plus 5 electrons plus Mn2 plus 4 H2O. Should be balanced. Let's see, electrons will cancel. Nice. And we'll be done. So if I rewrite it, fair copy. Goes to 5 Fe3 plus Mn2 plus 4 waters. Balanced. Next one. Hold on. There we go. All right, concentrated zinc solution. Go ahead and do this one. Pause me when you're done. Reactivate me. Welcome back. So zinc plus nitrate. You need to know your polyatomic ions. Goes to zinc ion plus ammonium. Right? All that information's in there. Separate into half reactions. Balance everything except O's and H's. Check. Balance O's by adding water. Check. Balance H's by adding H pluses. Check. Balance charge. 0 on the left plus 2 on the right, so I get 2 electrons. Do the same thing for now nitrate. Nitrate goes to ammonium. All right, N's are balanced. Check. Add O's, so I need 3 waters on this side. I have 6 H's here, and I have 4 here, so the total is 10 H's. So I need to add 10 H pluses on this side. Then I balance the charge. Net charge on the right is +1. Net charge on the left is, oh good heavens, +9. So it looks like I need 8 electrons here. And my strategy is just go ahead and pull the trigger on doing it and then double check that I say I'm right. So 8 minuses and 1 minus is 9 minuses. 10 pluses and 9 minuses is +1. +1 is +1. Balanced. Nice. Now we combine them. All right, we have 2 electrons here. We have 8 electrons here. So it looks like we need to multiply by 4. So 4 zincs plus 8 electrons plus 10 H pluses plus nitrate gives me 4 zinc 2 pluses plus 8 electrons plus ammonium plus 3 waters. These guys cancel. Sometimes some other stuff is going to cancel, waters, things like that, but it doesn't in this case, so we are done. So if I rewrite this, plus ammonium gives me 3 waters. That should be balanced. One more example. This one has the added twist. We haven't seen step 6 yet. This is alkaline solutions, which means basic solution. All right, now we combine them. We're going to split them into half reactions, and you just find the stuff that looks like the other thing. So ClO2 looks a lot like ClO2 minus. All right, follow the steps. Chlorines are balanced. O's are balanced. H's are balanced. I have a -1 on the right. I need 1 minus on the left. Balanced. H2O2 goes to O2. Everything except O's and H's is balanced. Balance O's, check. Balance H's, 2 H pluses, 2 H pluses. Charge 0 on the left, it's neutral, and +2 on the right. So if I add 2 electrons, that'll cancel, or it'll balance. 1 electron in this reaction, 2 in this one, so I need to multiply by 2. So it's going to be 2 electrons plus 2 ClO2s plus H2O2 goes to 2 ClO2 minuses plus O2 plus 2 H pluses plus 2 electrons. All right, I cancel the electrons, and that would be the reaction balanced under acidic conditions. And how do we know this? Remember, what is acidity? It's the presence of H pluses. Right, at a pH of 7, the number of H pluses equals the number of hydroxides. Under basic conditions, you have excess hydroxide. So we want to convert our protons in a way that gets rid of them, and then we only have hydroxides. So the shortcut or the trick we're going to use is that I'm going to add the same number of hydroxides as I have H pluses. Should have been a 2. Those are going to react to give me waters, right? But now if I don't add 2 OHs on this side, it won't be balanced, so I do. So we add enough hydroxides to both sides to cancel the H pluses and then simplify. So this is going to be 2OH minus plus 2ClO2 plus hydrogen peroxide minus plus O2 plus 2 H pluses and 2 hydroxides gives me 2 waters. Nice work by you. All right, this is now balanced under alkaline or basic conditions because I have the hydroxide instead of the H pluses. All right, that's it. So that's how we balance. You should practice. Look at all this super fun practice I have for you with all the solutions, the answers. And mostly it's just about keeping track of stuff. If you're not getting the right answer, it just means you didn't multiply right or you weren't really careful. So just go ahead and start again or take a look. Keep an eye out for this. I didn't have a lot of examples of balancing all the atoms. Really, the first one we did, and that was it.